The next talk is by Khuyen and Yibei. Khuyen is a developer advocate, and Yibei works as a data scientist, and they are going to talk about multi-series forecasting at scale today.
Hi everyone, I am Tran, and today we're going to talk about multi-series forecasting at scale with StatsForecast. I am Tran. I am a developer advocate at Nixler, where I spend a lot of my time on figuring out how to make time series forecasting accessible to everyone. I am also the author of the book Production-Ready Data Science, which teaches data scientists how to bridge the gap between prototyping and production. I also publish daily content on Python and data science open source libraries and break them down into code snippets that are digestible in 2 minutes. You can learn more about me at Codecode or just scan the QR code.
Hi everyone, thank you so much for joining us today. My name is Yibei Hu, and I'm the data scientist at Nixler. If you want to connect with me, you can scan the code on the left, and I'd like to talk briefly about Nixler, our company. So at Nixler, we are building a state-of-the-art forecasting ecosystem. And if you don't know about Nixler, you're missing out. And please scan the code on the left to learn more about our great company. Okay, so for today's speech, I think that we are going to be covering the topic about multi-series time series forecasting. And I know that this is a common topic, and in our daily life, we're constantly in the situation where we have thousands of time series to be making the forecast. So in today's presentation, we are going to go through that problem and see how you can leverage the Nixler tool for tackling it. So first of all, Khuyen is going to give us a brief introduction on StatsForecast and how to use the open source package for solving the problem. And after that, I will be trying to use TimeGPT, our foundational model, to tackle the same question and compare the performance with that of StatsForecast. And finally, we are going to go over the Nixler AI, which is our agentic tool for our most recent innovation for tackling the same problem using the AI agent to solve the time series forecasting problem in one go. And back to you.
Thank you, Yibei. So let's start with a scenario. Imagine you have multiple time series to forecast. Now, the question is, which model should you choose for each time series? Should it be ARIMA, ETS, or just a simple naive model? Now, you can have an easy way and just use one single model for all time series, but that will reduce the accuracy. However, using multiple models for testing multiple model for each time series is time consuming and doesn't scale. So what is the solution? That is where Nixler comes in handy. Nixler is a time series forecasting ecosystem that offering both open source libraries and a foundational model. In this tutorial, we're going to explore both libraries. One is StatsForecast, which is Nixler open source library for statistical models. And the second is TimeGPT, which is foundational model pre-trained on millions of time series. Let's start with StatsForecast. What is StatsForecast? It is an open source Python library that offers a variety of statistical forecasting models. It is one of the most widely used forecasting library with over 20 million downloads and over 4,600 GitHub stars. There are multiple reasons why you should choose StatsForecast. First, it is very fast because it uses number under the hood. It is 20 times faster than PMD ARIMA, 1.5 times faster than R, 500 times faster than Profit, and 4 times faster than star models. It is also very scalable. It is built on parallel execution, which means you can leverage multiple cores. It is also compatible with distributed computing framework like Spark, Ray, and DAS. It also provides familiar scikit-learn interface with the fit and predict methods, which means that you can learn and use how to use StatsForecast very easily. StatsForecast is a faithful implementation of our forecast package, which is the gold standard for statistical models. It also provides 9 model families, which you can see over there, with over 35 forecasting methods. Let's walk through how to use StatsForecast to forecast a real-time time series data. So here you can, we are looking at the A retail time series data, each recorded at hourly interval. We're gonna plot 4 out of 8 time series data. Here we use util_forecast, which is another Nixlab library. Here you can see that there's a variations in patterns in each of these series. Some with a daily rhythm, some going upward and some going downward, and some are quite volatile. First, let's start with the baseline models. Here we're looking at the naive model, which simply uses the last observed value as the forecast. Then we look at seasonal naive, which repeats the value from a previous cycle. In this case, it is the value from 24 hours ago. Let's plot the results. We can see that the forecast from the naive model, just a purple line, a flat purple line that's starting from the last forecast value. And the blue line represents the seasonal naive, which had the seasonal daily rhythm pattern. Now let's move on to more advanced statistical models. Here we're gonna look at 4 different models. The first one is AutoArima, which handles autocorrelation, trends, and seasonality. This is ideal for the data with complex temporal patterns. And then we have AutoETS, which auto-selects smoothing components. This is ideal for the data that has predictable seasonality and trends patterns. AutoCES offers flexible cyclical pattern modeling, which is ideal for gradual and repeatable variation, data with gradual and repeatable patterns, very repeatable variations in the signal. And we have AutoTheta, which offers fast and robust forecasting. This is very ideal if you want just have a good model that can have good performance for most time series. Now let's plot the results. We can see that most of the models follow the seasonal patterns pretty well, and it also good at capture the variations in the patterns. Here we compare the advanced models with the baseline models using MASE, which stands for mean absolute scale error. This metric compare all the models with the baseline model, and in this case, we choose seasonal naive. If the MASE is less than 1, that means it beats the baseline. We can see that the naive AutoTheta and AutoETS have the MASEs greater than 1. That means that it doesn't beat the baseline model. However, the AutoArima and CES model has the MASEs less than 1, which means it outperforms the baselines. Let's move on to cross-validation. Cross-validation is a technique that tests how good a model is when working with new data. In traditional cross-validation, you would randomly split the data into train and test set. In time series, this is not ideal because it let the model look into the future values, which could cause data leakage. StatsForecast cross-validation fixes this by ensuring the model trained only on historical data and not future values. To understand how StatsForecast cross-validation strategy works, let's look at this interactive graph. First, we train all the model on the initial window in yellow. Then we forecast the next period, which is in red, and evaluate the accuracy. We slide the window forward, add new data to the training set, and repeat the entire process. This allows us to have robust model comparison without using the future data. Now let's see how to do cross-validation with StatsForecast. Here we do cross-validation with 24-hour forecast horizon. We move the window forward 24 hours and repeat this process for 2 windows. We then use the compute MAE for each model across multiple windows so that we can pick the best model for each series. Now let's plot again. Here you can see that there is a blue band. This is the 90% prediction interval. The wider the band is, the more certain, the less certain the model is about the forecast, and the tighter the band, the more certain the model is about the forecast. And you can see over there, there's pretty much no prediction interval band because this is a forecast that is very predictable. The pattern is very predictable. Now let's compare again the best model selection with other models. We can see that it had the lowest MASE. What this means is picking the best model for individual time series outperforms picking using one single model for all time series. Now I'll hand it over to Yibei for TimeTBT.
Right. Thank you so much, Khuyen. That's a great introduction on how to use StatsForecast to make the time series forecasting task easy. So now let's up the game more in a next level. I'm going to briefly talking about TimeGPT, which is Nextsla's foundational model that can help you to solve the problem just in 3 lines of code. So first of all, what is TimeGPT? TimeGPT is Nextsla's foundational model for time series forecasting. It is a foundational model that is pre-trained on millions of time series from diverse domains, which gives it the ability to generalize the patterns, pattern learning from different time series. And since our launch for TimeGPT 1 2 years ago, we have seen wide adoption for TimeGPT to be in various industries like inventory management, demand forecasting, and finance, for example. So that it is very fair to say that nowadays, foundational model has almost become a standard tool in the time series forecasting toolkit. So building on that success, just last month, we have been launched our 2nd generation of TimeGPT, the TimeGPT 2. Which is delivering a higher accuracy and better performance, and it is achieving almost 60% better performance compared to that with TimeGPT 1 on various test benchmark. So with that said, why you should choose TimeGPT and why you should try it out? So first and foremost, the most obvious reason is that TimeGPT is providing you with the out-of-the-box, very accurate and fast way to make the time series forecasting task both easy and less torturous. Unlike the traditional model, which is requiring the local training and fitting, TimeGPT is only involve a single API call to the cloud, so it doesn't require the local training. And also, the second reason why you should try TimeGPT out is that it is extremely simple and user-friendly. So how simple can it be? In the previous section, we have been seeing that all the effort for model selection, for model tuning, and parameter tuning. For TimeGPT, you can simply complete that in this one line. As you can see, the only thing that passes into this call is the train set you're going to use for the time series forecasting, the step you're going to be forecasting into the future, and lastly, the frequency of the time series data. And all with this one call, you are able to make a fast and quick forecast for the data set for yourself. And as a data scientist, I understand that sometimes it is not really enough that you're getting the final answer. So you have to have that level of control over how and what the model is producing, right? So TimeGPT is also giving you that ability to control, to a certain extent, what the model is doing. So for example, if you want to have a more accurate forecasting, that is manipulate the model to ask it to be more knowledgeable about your data, you can use the fine-tune steps. You can add the fine-tune steps or adjust the fine-tune depth to make it more accurate for you. And also, in some case, you can change the model to use. For example, you can use the TimeGPT-1, but now you can also use the TimeGPT-2, our newly launched model. And in some case, if you're forecasting into the future for a long period of time, you can use the long horizon model. And another functionality we have is the conformal prediction. So simply putting the confidence interval of your choice into the level parameters, you're able to get the conformal prediction instead of a point estimator. So with that said, I'd like to give you a little bit demo about how to use the TimeGPT. As we said before, the TimeGPT is only one line of code, and to call it, you simply need to first import the package, and then you initiate the client for making that API call. And thank you. And finally, you just passing in the forecast call. And that's basically all you need. You can see that it is immediately executable, and within two seconds, you are able to get the result. So here we have 3 different versions of the same call. First, we have the TimeGPT-1 vanilla call. And secondly, we are adding 10 fine-tune steps to make it more accurate for our data set. And finally, we are trying out the TimeGPT-2 model. So we are going to be comparing their performance a little bit. OK, now there you go. Right, and then we are merging the result to check. Probably you can see the result here. Here we can see that both TimeGPT-1 after fine-tune and TimeGPT-2 are having MASE less than 1. Again, this is the metrics to compare with the naive, seasonal naive model. The smaller the number is, the better it is performing. So we can see that with TimeGPT-1 fine-tune, we are getting almost 20% better performance than that of the seasonal naive. And for TimeGPT-2, that's 60% better than seasonal naive. We are plotting the result, and we can see that in 4 of these cases, TimeGPT is able to capture the seasonality, the trend, and in general the fluctuation as well for the time series. And we see that the shallow band here, these are the conformal prediction, which is the confidence interval basically for how confident you are for that prediction. And finally, we are making a comparison between the model. You can see that the purple models here, they are the naive model, and this one, it is the best model selected from the StatsForecast model. We can see that the fine-tuned TimeGPT-1 is here. It is better than the seasonal naive, and the TimeGPT-2 model is even better than the best model selected from the StatsForecast cross-validation. And there is another aspect of TimeGPT performance that I want to stress. Literally, that's going to be the time consumed by TimeGPT to make the forecast. So if you can see for traditional model such as StatsForecast, it is requiring the local branch training and fitting. So in my case, I'm using my computer, 8 core computer CPUs, to make the forecast train and forecast for 5 StatsForecast model, and it's taking me around 3 minutes to finish the call. Of course, you can speeding it up by distributed computing or parallel processing. However, you can see that the performance time for TimeGPT is basically just 2-3 seconds. So compared with the traditional model, that is almost instantly that you can generate the forecast result. That's another reason why TimeGPT is so applicable to the real-world scenario where you may be having like thousands or millions of time series data to be make the forecast for. So just to wrap it up, TimeGPT versus StatsForecast, when, where you should use it. So first and foremost, TimeGPT is a foundational model. So maybe it is not going to be providing the explainability the same way that StatsForecast is doing. However, in terms of speed, scalability, and accuracy, TimeGPT is extremely fast because it is not like the traditional model. It's going to be 0 shot and only involving an API call. It is super scalable, handles thousands of time series instantly via the API, and there's no need for local compute. And in terms of accuracy, TimeGPT is very accurate, especially in the case where the data is complex, it's noisy, and doesn't show much seasonal trend in it. However, for StatsForecast, it is our package hosting the classical statistical model. I know that there are a lot of supporters for statistical model. It is very nice that it is supporting and giving very clear mathematical explanation of why the model is generating the forecast. However, in terms of speed and scalability, it is requiring the local compute. We do have great implementation and great functionality that support the parallel processing as well as distributed computing, but that's still much slower than that of TimeGPT. The StatsForecast is very accurate during the time that there are structured or seasonal data, as we saw in our example. So that's going to give us to the last part of today's presentation, which is Nextla AI, our most recent innovation at Nextla for agentic solution. So the project is that we are going to be bridging the language model over to the powerful foundational TimeGPT model. So the idea here is, yeah, I'm going to zoom in. Right, the idea here is still that we want to make a end-to-end forecast for the problem we saw before, 8 time series forecasting. And we want to compare the performance of TimeGPT 1 and 2. However, this time we want the agent, AI agent to do the work for us and generate an end-to-end solution from the start. So as you can see here, I'm using Cloud as the interface for our MCP integration. However, you can choose the AI agent of your own pick. It's going to be working as well. I'm just interacting with the AI agent with plain English. So as you can see, I'm asking it to make a 48-step forward forecast with TimeGPT-1 and 2, evaluate against the test set, and finally compute and compare the MASE, MSE, SMAPE. So these are exactly the same metrics we're using in the previous part of our presentation. And also, I'm going to be pointing it to the train and test data set. As we can see, the agent is immediately generating the plan for how it is going to be mapping out the forecasting problem. So one thing I really like about the agent tool is that it is not only helping you to generate the code, but also it's managing the execution in the backend. At the same time, it is helping you to think about what you want to do with the problem. So as we can see here, it is generating an analysis plan. So for here, it is first going to do a data pre-processing, then generating the forecast, and finally using the model evaluation tools to calculate those error metrics. And here, I noticed that it is misunderstanding the TimeGPT-2 as TimeGPT-1 long horizon. I know this is not correct, so I'm able to interrupt the agent and tell it where I want to change. After that, the agent is able to upgrade the plan and reflect the real thing that I want to do here. And finally, it is executing the code. It is first generating the code and then executing it in the backend and finally getting the result. So first of all, we have the data pre-processing. We can see that it is checking the format and missing value for the data set. And in this case, it is telling me that the data format is correct. And it can actually help you to do the pre-processing if it finds out the format is not matching. And the second step is that it is making the forecast with TimeGPT-1 and 2. You can see here, it is generating the code block. This one is for TimeGPT-1 here. And also generating the code for TimeGPT-2. And after that, it is using the model evaluation tool to calculate the metrics. Here. At the end, we can see that the agent is also getting the same answer as what we have been manually computing. And the TimeGPT-2 is almost 60% better performing than that of TimeGPT-1. And it's also giving a small analysis on the result as well. So with that said, I think we have been showing how powerful it can be to merging the power of language tool as well as the foundational time series model. And also we have been showing that TimeGPT-2 is performing much better and much powerful than TimeGPT-1. So currently we are on our beta phase. We are inviting our user to try out our model. So if you are interested, please scan the code, and we are going to be prioritize your request. And thank you so much. I think that's all of today's presentation, and I will be seeing that these are the GitHub repo and the Nextcloud website. You can join our free community Slack. And if you want to run the repo on your own time, please go ahead. Yeah, thank you so much.
Thank you very much. Questions?
Thank you so much for your presentation. I was very excited for this session because I work with forecasting directly, and I'm actually actively seeking forecasting tech for my work. As I'm trying to weed out the tech, I wonder if you have comments on how TimeGPT handles zero inflated series. In my line of work, I work with a lot of very heavily zero inflated series, and most of the time I use evaluation metrics like Tweety deviance or like Poisson deviance because it's a count type data and again zero inflated. I know that it's a very powerful tool, TimeGPT, and you train it on like millions of cases. So I wonder if you have comments on that, and do you think that it's going to be a good engine for zero inflated data?
Yeah, thank you so much for the question. Actually, we get that a lot, like how to deal with intermittent data set where zero are there going to be in the data set. So actually, I would say that it's a very scenario-based question, like how are you going to make use of the tool, or how are you going to be generating the result? What kind of goal you want to hit with the time series forecasting? So I would say that the approach you are using, for example, using the different metrics, is a good way to approach the problem. And TimeGPT is also going to be generating result on your dataset. However, I think what is very important is to like understand the scenario and probably do some pre-processing or post-processing to better interpret those results generated from TimeGPT. But yeah, again, like this is a very flexible and very scalable tool, and it's definitely going to be very powerful in the real case in your scenario.
So besides the, oh, sorry.
I just want to add to that, like we have actually StatsForecast. What we often do is we use StatsForecast, which we showed earlier, for like pre-processing, and it have a function for you to fill in the gaps for those intermittent data. Then we're gonna use, after filling the gaps, then you can use TimeGPT. And yeah, so like we often combine different solutions, and with StatsForecast, it's very easy to pre-process.
Yeah, does that answer the question?
Yeah, absolutely. Can I ask one very short question?
Definitely.
I wonder, so does it take in series with different historical data in one go, or does it have to partition into different forecasting projects?
Yeah, actually, that's a very good question. So how TimeGPT is dealing with that is that you are having a column. It's called unique ID. Yeah. So that's the identifier for which series it is. And with the unique ID, you're able to just make one call to the whole data frame. That's including multiple time series, and that's it. That's all.
Doesn't matter the different history in each series.
What do you mean? I'm not getting the question actually.
Just, like, I know that one call would apply to the every single series, right?
Yeah.
But, and for example, if I want to predict like 7 interval ahead, but the series have different interval lengths, is there a mechanism that they handle the different lengths of the series, or that's the data pre-processing part?
You mean the step you want to make into the future, forecasting to the future, is different for each time?
No. The history available.
It doesn't matter. Like,
I see,
like you can
okay.
pass by different lengths.
Thank you.
Next question.
Thanks for the talk. Do you guys take in exogenous features?
Yes, we do. Like we can incorporate both historical and future exogenous variable in TimeGPT for making the forecast. And adding up to that, we also have a model explainability feature which is using the sharp value to explain how much, to what extent the extraneous variable is impacting the final forecast. Yeah.
Hi guys, thanks for the insightful presentation. Just a couple of quick questions. So I think you mentioned the prediction interval is from conformal prediction, is that right?
Yeah, so the conformal prediction is generating the band that you have been seeing in the time-GPT forecasting.
I see. And can you give me a brief overview, like what does it do, like that technique?
Yeah, so conformal prediction is a uncertainty quantification method. So basically what it does is that it is calculating the error in the past period, and having, for example, 80 or 90% of that error, and adding that to make a band instead of a point estimator. So, yeah, does that answer the question?
I see. Yeah, no, I think that makes sense. And second question, kind of similar to what the other person asked, other user asked. So instead of, let's say, zero inflated series, you have a series which does not have a known horizon, or like you said, is like intermittent, like it's sampled at different points of time, not regular spaced. Can the time GPT handle that?
In that case, I think that's where the agentic AI will be coming into the picture. Actually, for time-GPT, it will require a standard format for making the time series forecasting. However, that's why we're having the agentic AI tool. That tool can help you with different interval and dealing with your data in a pre-processing step, and helping you to do the time series forecasting in one go.
I see. Thanks. Very helpful.
Also, what I'm showing the screen kind of shown what you asked earlier.
Yeah, this is our tutorial for extraneous variable and how to incorporate it into the forecasting.
Next question.
Do any of your agents either now or plan to handle time series tasks that aren't forecasting? So like motif discovery or classification or clustering. Is there any sort of interface that your agents have with those sort of tasks?
That's actually a very good aspect. I haven't think about it. Like for now, I think most of the agent power is focusing on the time series forecasting. But what you described, like the clustering or other tool, like other functionality of time series analysis, yeah, we will be thinking about it to include it in our future generations. And also adding upon to that, we do support the anomaly detection function for time-GPT and Gen AI.
Thank you. I think we've got time for a very short question, the last one.
Thank you. Great presentation. I was wondering if when you generate the series, do you include the industry as a filter? Like, for example, if it's the retail, pharmacy, or energy?
Actually, that's a good question, and a lot of our customers is asking like whether or not we are generating like using the model to filtering out the domain. But unfortunately, the answer is no. time-GPT is a pre-trained model that is for all domain. So you can fine-tune the model. However, you cannot say, okay, so this is retail or this is which sphere is it? That's going to be making it more like context-based and less generalized. So I guess this is what you have to think about and consider which way to take. It's more like a philosophical question, like what you want to accomplish with the tool. So no, we don't take the domain filters.
Well, let's thank our speakers again.